help, but I will not cover them in the lecture. So instead of 5 lectures, we will have 1 lecture on reviewing. Okay. So that is the assumption. The other assumption is that you have some background in programming. Programming is easy for a course like probabilistic machine learning as opposed to, let's say, a course like deep learning. So deep learning requires much more programming, whereas in probabilistic machine learning you will need much more of mathematics. So you have to derive things, and based on the derivations you will have to write programs. Okay. Along with that, you will also need knowledge of linear algebra, but I think that all of you have to a certain degree. So linear algebra will also be needed. Optimization, some knowledge is helpful, but we will see about that. But anyways, any machine learning course I always say is nothing but combination of linear algebra, probability statistics, optimization, programming, and if there is a mechanics term, then mechanics. If there is no mechanics term, then that is not needed. Okay. Now the course code is APL 744, and I am telling you that, you know that, because what I want you is that any doubt you have, you can write to me, but please include this code in your email title. Otherwise, I might receive another 10 emails, and your email might go to some folder which I will not keep a track of. Okay. So if you want a response from me, please include APL 744 in the title or the subject of the email. Otherwise, you might not get a response from me. Okay. So this is the second time this course is running. So last year we already had this course, and last year I recorded all the lectures. Okay. So all of that is available to you as a reference material. You can go and check it out. And it is better that, because you will know beforehand what I am going to cover in a given lecture, so it is better if you see it before coming to the lecture. That will make the learning process smoother. Otherwise, you might have to watch it 2-3 times, okay, because there are a lot of derivations that are involved in this course, and you will not be able to follow until and unless you are doing it yourself. Because when I do it, it will seem like, okay, it is doable, it's not that difficult. But if you are not doing it yourself, and you can ask if you know someone who have done this course last time, like the TS, out of 2 TS did this course last time, you can ask them, they will tell you the same thing. Okay. The course will have multiple components including homework. So there will be 4 homework, practicals 302, 5 practicals. There will be a project component, term project, and obviously minor and major. Okay. Minor will be MCQ based, Moodle kind of setup. Major will be written pen and paper kind of things, where derivations and all those things will be asked. Okay. Timing, you know, 9:30 to 11 Monday and Thursday, but what we need to decide is the practical timing. So obviously second half, 1 day. So any preference, any day? Longer. Wednesday second half 3 p.m. onwards. Okay. It will be 2 hours, less than 2 hours in most cases. Okay. TS, there are 3 TA in this course. Subankar is here. Apart from that, Tapas and Sawan are there. So I told him not to come. I forgot to tell him not to come, but so he came. But that's okay. So TS will not be attending the class, but they will be helping with the practical part, homework part, and those kind of things. Okay. Other things I will handle. So now, website, right? So this is the website for this year. So all the homework for this year, practical for this year, everything will be here. This is for last year for your reference. If you want to see the videos, if you want to see refer the lecture notes, if you want to see the homework from last time and all those things, this is the one. Okay. Obviously same course, so 80% to 90% will be same. But there will be some things which will be new this time, which were not there last time. And that is the reason I am removing that probability part, to make space for those additional things that I could not cover last time because I was reviewing stuff. Now a heavy slide, so let us go through it slowly. Total you will be given 4 homework. Okay. Each homework will involve problems where you have to do derivations and problems where you have to write codes. Generally these two parts will be linked, so you can think of part A as the derivation part, part B as the programming part. Okay. 5 practical set, actually 4, I'm counting 0, 1, 2, 3, 4. I'm saying 0 because the first practical will be next week, not this Wednesday, next Wednesday. And by that time you will not have knowledge to do any practical as such from this course, so that will be like some background kind of practical. So actually 4 practical, but practical 0 also. So homework, it has 25% weightage, and I will take 3 out of 4. So base 3 out of 4 to give you some relaxation. So you can, so I will grade the base 3 out of 4, and based on that, that 25% weightage will be there. Practical, although there is 5 practical, I will take 3 practical from 1 to 4. Practical 0 I will not grade, that is just for your practice and review part. Practical 1, 2, 3, 4, out of those I will take base 3. Okay. And based on that you will have 15% weightage there. Term project, 20% weightage. The idea is that, so I will tell you more about it, but you can think of it as you will do some real implementation on reproducing certain papers that are already published in this area. The paper you will yourself select, the big domain I will provide. Okay. Minor and major, 15 and 25% weightage. Minor will be MCQ based on Moodle, so and it will most probably happen before the minor date. So for example, if the minor week is 12, let's say 12 I think is starting, so it will probably happen on 8th or 7th. So just before that, so minor, whatever date is there, you will be free, so there will be no exam. Major will be on the normal thing. Okay. In case you decide to audit the course, 40% is what you have to get for audit pass, and you will have to complete the project. If you don't submit the project, you will not audit pass, you will get NF. And the reason is that project will be done in teams, so if one of the member is auditing, the other will suffer, so that is not allowed. So that is why that is done, and you have to appear for both minor and major. Okay. And this 40% can come from everything. It's not like that from this you have to get 40%. From everything out of you can get 40%, but you have to appear. You might get 0 in minor, 0 in major. Just come, give attendance, go, I'm fine. If you think you have got 40% without that, but you have to appear. Okay. So this I think is the important slide. I'm already giving you the tentative dates when the homeworks will be there. The first homework will start somewhere towards the 3rd week of August, because by that time I will need that time to cover things that will be given in the homework, and the submission is September 15, so like 15 days, 2 weeks kind of time you will get. Now when you receive this homework, it might be possible that some of these questions that I have given in the homework are not yet covered in the class, but definitely those will be covered before this date. Okay, so keep that in mind. So, but obviously it will not be covered on 3rd, it might be covered on 25th or 27th, so that happens. Okay. And like that, these are the dates. So November 5th is the last date. I don't want anything after that, because I think the last work class is November 14th or 17th, something like that. So 10 days before that I want to wrap up this. Practical, I have not mentioned it because I did not have the, like when it will start I was not aware of, so yeah. So practical, as I said, practical will start from next week, so next Wednesday, which I believe is 31st of July, and each practical will be over multiple weeks. So we will start this week, but we might not finish in this week. And practical will be the easier part. Homework will be the difficult and more conceptual part. Practical is, the idea of practical is that we want to, or we means me and a team of TS, want to teach you how to write codes, how to do derivations, small things that are conceptual. Homework means application of the knowledge you are gaining by studying this course. So it is whatever you are studying plus some delta is there. Okay. So this will actually be the easier part. Homework will be the comparatively more involved one, and that is also reflected by the fact that homework has, I think, 25% weightage, practical has 15% weightage. So that is the reason. Okay, and you can see that some of the practicals can go over 7 to 9, right? 7, 8, 9, so 3 weeks and all those kind of things. So practical, how will you proceed? You will be given a practical sheet. We will discuss that in the class, how to do that. You have to do that, and it is not necessary that you have to only do it while sitting in the classroom. You will do it there, but you can also do it at your own convenience, at your hostel, home, wherever, house, wherever you are staying, you can do that. That's fine. And there will be a deadline at which you have to submit it. Okay. And for practical and for homework, you have to write proper reports for submitting them. Like, suppose I get some result. If you only submit the result, you will get 0, because that makes no sense. You have to explain the results, you have to explain the algorithm that you use to get the results, and you have to explain everything about that. Okay. So that is, so yeah, so that is it for practical. Then there is term project. Here the idea is that we will provide you a pool of research areas. So I'll circulate a, let's say, a Excel sheet with, let's say, pool of some number of research areas, and you have to fill that up. Okay. Now, what happens every time, and will happen this time also, that there will be some research areas which will be like hot research areas, and there will be some areas which were not many are willing to do. Okay. So this research area will be allotted first come first serve. So if you have come first and claimed a research area, that is yours. Whoever comes next cannot have that, have to select something else. So that means whenever I circulate, be fast. If you come at the last moment, you might not get that area, or get an area of your first choice. Okay. Once you have selected the research area, you will now have to select a paper from that, which you will decide that you want to reproduce. So it is you have the freedom to select a paper from the research area which you got. Now, what kind of paper you should select? Obviously paper where data is available, because you don't want to spend time in generating data. So select paper where data is available. There are abundance of such papers in machine learning. So select papers like that, and then it's straightforward. Read the paper, understand, reproduce the result, prepare a report, make a PowerPoint. Okay. So basically it's all about reproducing a paper and presenting it so that we know that how much you have understood. That is the big level idea. Okay. What are the purpose of these 3 components? I think it is important for me to explain. The idea of homework is to test your overall knowledge, because that will be like homework from different areas. Okay. The purpose of practical is to teach you and to assess your fundamental understanding, and to teach fundamental programming, some aspects and all those things. The idea of term project is the most important, and the idea is that we will be covering so many things in this course, and it is impossible for anyone to understand all of those. Even I cannot claim that I understand everything that I will be covering. I will understand it at that point, but there is a limitation. There can be more details that I probably need to go, and there might be more details that I might be missing even myself, right? So the idea of this project is at least there will be one topic which you will understand in absolute detailed manner. So that is the idea of the term project, that there is at least one project where you understand everything. Whereas in other cases, you understand, let's say 50% of the idea, which is fine. Okay. And major and minor are usual things, so I don't need to explain that. But one thing, so term project, you have to submit 4 reports. Why 4 reports? Because I don't want you to work only in the last 2 weeks of the semester. So 4 report will ensure that you are working continuously. The first report is on review. So once the paper has been selected, you just have to review the paper and the area where it stands, and that is simple. Okay, that will have less weightage also. The next 2 are reports that will show that you have started implementing. Your code might not be running at that point of time, fine, no problem, but you should submit your code that will see that okay, you have started right, you have written something. There might be some bugs that it might not have come finished, and that is fine. But you have to submit code in report 2 and report 3. Report 4 is last report, so everything should be working. Even if it is not working, remember that we are not trying to, so this is not about you reproducing a paper. It is not only about that, it is about you, or it is about judging how much you understand that paper. So it is possible that at the end also your code is not running. Don't worry. Yes, some marks will be deducted, but that will be very minimal. You will be mostly judged for your understanding. Obviously, those who have done it completely will get more marks. They should get it. But does not mean that I will penalize and give you 0. It does not work like that. And that is another reason that we have divided into parts. So even if the last part you were not working, you have got marks in the previous, right? So that's how it is. And then there will be a seminar presentation kind of thing. That might be before the major or after the major, that will decide mutually. Okay. I think last time I took before, and then before that I took after. So it can be either ways. So it's fine. So one presentation at the end. Okay. Now, yeah, there are some dates when the reports will be due. I think this is same as last time. I did not edit this slide, I guess. But you will realize that the project last report is October 30th. So again, I don't want anything in the last 2 weeks, 1 week, because that is the time you'll probably prepare for major exam of all the subjects you are taking. So it's not about that I only, so that's why I don't want to bother you at that time. Okay. Final presentation will still be pending, but that date we will decide, or I will not decide, we will decide. Books, right? So I will suggest, so we will be very closely following this book. Okay. The notes that I have are mostly from this book. So I think this book is available in library, but not many. So please go and collect a copy if possible. If it is not possible for you to collect a copy, it is fine. The notes will mostly be self-sufficient. So you might not need it, okay? Because you realize the notes will have 2 parts, one that I will write during the lectures and one that I have already typed. So the typed portion are like equivalent of the books, there will be no mistakes, everything will be very formal and all those things. The portions I am writing will be more casual so that you can understand and follow the class. Okay. So book is not, it is not absolutely necessary to have a book, but it is good to collect this book if possible. Okay. This is also a good book, but this is more like an encyclopedia. This is everything possible there. So whereas this is much more detailed. And this book, the last one, is only for certain topic, and I think this one is available for free online. Okay. So this is only for Gaussian process, which we will cover, and for that portion we will be referring to this book. Okay. But otherwise, this is the main textbook for us. Okay. Coming to the syllabus. Okay. So obviously, as I said, one lecture on this part, we will be reviewing the statistics and probability part very quickly. So if I repeat that if you want a refresher on probability and statistics, go to last year's recorded video, recorded video and lecture notes and refer those, see it in your own time, and then you can always come to me if you have some doubts, and I will be happy to discuss. Okay. But this time around, this will be like one quick lecture. Maybe the next lecture, Thursday, I will do that. Okay. And after that, the course is on probabilistic machine learning. So there will be topics like priors, there will be topics like likelihood. These terms might be foreign to you, might be known to you, depends how much some of you have learned in APL 405. The UG ones, UG students I'm talking about, and for the PhD ones, probably these terms are new, which is fine, don't worry, we will cover it in details. Okay. So prior, likelihood, posterior predictive, plug-in approximation, all of these are Bayesian concepts which we will cover in details. Like prior might have, I don't know, 2, 3, 4 lectures on this, that. Okay. So we will cover those things in details. Okay. And then we will be talking about Bayesian linear regression. And in the context of Bayesian linear regression, we will be talking about how to do Bayesian linear regression analytically, how to do Bayesian linear regression using sampling method, so all of that, how to do Bayesian linear regression using approximate inference, which is variational approach and all those things. And this itself will take, I don't know, 10 to 12 lectures kind of thing we are looking at. Okay. So we will spend significant amount of time on this. 10 to 12 is like out of 28, right? So that's a significant portion that we'll spend until this point. Okay. Then we'll go to Gaussian process. Gaussian process also will have 7 to 8 lectures, maybe more, maybe little less, where we'll talk about Gaussian process, we'll talk about sparse Gaussian process, where we'll talk about different types of sparse Gaussian process, we'll talk about GPLVM, which is Gaussian process latent variable method, and the plan is that I want to talk about deep Gaussian process also, but if time permits, that part I might skip. So that will take time. Okay. And then we will talk about unsupervised learning. We'll talk about unsupervised learning in a short while. So we'll talk about probabilistic PCA, latent variable model, and GPLVM is also a unsupervised learning method. And we'll end the course with neural networks, probabilistic neural networks, such as two models mainly, diffusion model and flow-based model. Okay. So these two are popular generative models that you can use to generate new music, generate new images, generate new videos, and so on and so forth. Okay. So that is where we will end the course. And because I wanted to include these two things, I have removed the probability statistics. So this is the main reason. I could not cover it last time. I did cover it in the deep learning course, but not in this course. So that is the reason. So I think at least one, I think there are more who have done deep learning. So for you, it will be repetition, but we will go into more details of this, because now I have that freedom of going into deeper aspects of probability and statistics, which I could not do in deep learning because we did not talk about probability and statistics. So yeah, this is for the modality of the course. Any question until this point? Because otherwise we will start with the basic introduction to machine learning after this. Yeah.
Is it mandatory to attend practical sessions?
So last time it was not mandatory. This time also it will be mandatory certain practical sessions and certain will be not.
As if we finish the practical week early.
Then you don't need to. Okay. So for example, when I say certain, right, the first week I will be discussing the concepts of the practical, right? That is you have to attend. That is when I will take attendance. Next week it is more about, do you have doubts, I will clear and all those things. That week is not essential until and unless I decide that I am covering something else. And if I miss some classes because of I am traveling to some conference or something else, those extra classes will be in the practical slot also. So that you have to keep that free either way. Okay. But otherwise, practical I will only take attendance in certain practicals where then either new things will be covered and I know that and all those things. If there is a practical which is only about doubt clearing session, then it's on to you, up to you. You want to attend, you attend. You don't want to attend, you don't attend. You can come and discuss about term project. I'll fine with that. So whatever you want to discuss, any doubts you have, I'll be happy to discuss. Okay.
And is there any format for the reports?
Yeah, new rips. So I'll submit that. Report means report of not the practical, report of the term project I'm talking about. So term project has a format and has a page limit of 6 pages, excluding references. So that will be provided to you. But report, there is no format as such. The only thing is that think that I don't know anything. Now write the report. Don't assume that I know the subject. So if you assume I don't know anything, you will write everything. So those reports would be self-sufficient. And this year I probably will select the best report among all of you and post it as the solution. Or maybe it might be combination of 2 or 3, and I might post it on my website with your name or whoever has done it, his or her name. So proper credit will be given, and that will be posted. So everyone will know that you were the best, at least in a given homework. So that will be done. Okay.
And is it necessary for the reports to be timed?
Timed?
Timed.
No. In fact, it is necessary for the report to be not typed. So typed report will not be accepted for homework and practical. Okay. So you have to write it. Okay. You can write it on tablet. That is fine, and share it. I don't mind that, but it has to be written, handwritten, not typed. The report of term project will be typed. Okay. So yeah, so that I forgot. Thank you for reminding me. So yeah, so the report, the idea is that it has to be handwritten, not typed. Anyways, that will be written in the disclaimer of the homework sheet. Any other question? Otherwise, I will start. So how many of you have prior knowledge of machine learning before I start? Like have done at least one course. You two have done 2 courses. Okay. Okay. Yeah, you have. Okay. So there are some who have no knowledge, right? Who might have heard about machine learning but have no knowledge, right? So why is this subject important? Someone wants to explain? Why is it important to study? I mean, what is machine learning? Why do we care about it? Why do we want to study it? Any idea? What is machine? What is learning? There are 2 terms there, right? How is it? Is it same as AI? That's a buzzword nowadays, artificial intelligence, or is it different? Is it same as deep learning or is it different? So anyone? Actually, those who have done should tell. What is machine learning?
Basically, the machine learns from experience.
And what is experience then?
Data.
Data.
So machine that learns from data.
Yeah.
And updates it.
Yes. So it learns from data. Okay. And it can learn in different ways, which we'll talk about. Okay. How is AI different from machine learning? Someone else? What is AI and what is machine learning?
Machine learning is a subset of AI and
correct. What is AI?
In general, machines able to do some reasoning tasks.
AI, not only reasoning, but AI is about intelligence, and you can relate intelligence to reasoning, but it might not be reasoning. Okay, it might only be prediction without reasoning. For example, all of us have heard about ChatGPT at least. And have you heard about AGI, artificial generalized intelligence? So that's a goal, okay? The idea is that as human being, we can do multiple tasks, right? Without forgetting. So we have a generalized intelligence. Artificial intelligence, the machine learning or artificial intelligence, both are different things, but a subset is, as he correctly said, they are very narrow. They can only do certain tasks. You have a machine learning model or AI model for, let's say, vision. You have a separate AI model for language. You have a separate AI model for, let's say, decision making, control. So it is very narrow. And one of the idea that people are now at least expecting is that with large language model like ChatGPT and those things, that is a step towards AGI. However, there is a other community, and I am a believer of that second community, who believe that AGI can never be achieved until and unless your model can reason. So right now LLMs are autoregressive model. They cannot reason. If you ask it to explain something, it will provide you an explanation that you want to hear, rather than the explanation of how it arrives at that result, which is not explanation. But if it is a causal model, if it is a model having reasoning capability, then it can reason and tell you the reason why it arrived at that result. So without that capability, a big fraction of AI researchers believe that it is not possible to achieve AGI. So causality is a very big area right now in machine learning, which is upcoming. I mean, and it is very likely that it will become huge very soon. And reasoning means causality, but most AI models cannot reason. Okay. Now I have a two-hour lecture on what is AI, but I will not do that here. But it's a detailed topic. There are 4 definitions of AI. Each one belongs to each. I mean, there is no one definition actually. But most of them believes that it is about AI is about developing or enabling a machine to act rationally. So it is more about acting rationally. So the 4 definitions are like thinking like human, acting like human, thinking rationally, acting rationally. So these are the 4 definitions, and most people believe that acting rationally is the thing. So it is not about acting like a human in most cases, although someone working in cognitive science will say that that's the definition because that's what they are working on. Because if you are saying that acting like human is intelligent, then we are saying we are the only intelligent being in the whole universe or multiverse, whatever, which is quite wrong probably because we don't know. There might be some more beings which are more intelligent than us, right? So acting rationally actually eliminates the human factor. Okay, and it is also about acting and not thinking, because how will you know something is thinking or not? For example, if I ask you whether this is thinking or not, whether can it think, how will you decide whether it can think or not?
What's the meaning of intelligence then? Like you said, someone probably be more intelligent than us. So what's the definition of intelligence for them?
Correct. Correct. So that is also not defined. Definition of intelligence itself is vague. If you do a dictionary search, there also the definition of intelligence is wrong. Wrong in the sense it is like the ability to reason, act in a human way or something like that. Okay, but that is more like if you are intelligent, you can do that thing. So that is the after effect of intelligence. That is not the definition of intelligence. Okay, and that is a dictionary definition. So dictionary.com, you go and search intelligence. So you will see that the definition is that it is the ability to act and take decisions in a rational manner, in a humanly way, or something like that. Okay, so but that is not the definition, right? And so I'm coming to that. So one of the definition or one of the things that people like to believe, at least in cognitive science, is that human beings are the intelligent ones, and we like to emulate human being, and that will be intelligent. But what do you mean by emulating human being? You will say that thinking like human. But how do you know whether a human being is thinking or not? How do you know I am thinking or not? You will only know whether I am thinking or not if you ask me some question and I respond. But what if I cannot speak? Okay, I'll write. I don't have hands. I cannot write. So then I'll give some signals. I cannot see, I cannot hear. Bad example, but obviously will not be able to judge that whether I can think or not. Okay. Similarly, whether this bench can think or not, you don't know. Theoretically, it might be possible it is thinking, but we just don't know because we cannot communicate it. So ultimately, it is decided based on acting, and that's why acting rationally. Also, we don't like to act like human. Why you will not like to act like human? Because human beings, for example, if I have a big fight, I will not have. I might be doing very bad in the class that I'm taking. You don't want your machines to go through that, right? You don't want your machines to go under depression, be sad, be happy, be crying, and all those things you will not want. What you will want your machines is to achieve a goal And that's what rational is in some sense, that minimizing some objective, achieving some goal. So that is what you can actually formulate in a mathematical way. Because at the end of the day, you will need a definition that can be written in a mathematical way. Because only then that problem is solvable. If I give you a vague definition, which like acting like human, what will be how will you write that in an equation form? What is acting like human? In an equation form, you cannot write that. So those definitions are problematic then. But from a philosophical point of view, that is the correct definition. So there is a philosophical aspect of AI, and then there is a practical aspect of AI. We will be mostly focusing on the practical aspects because we want you to solve problems at the end of the day, right? So anyways, so I was talking about, or I will talk about now, machine learning. And the idea of machine learning, as correctly said, is that you want your machine to learn from data. Now there is a different class of machine learning algorithms where it learns without data, learns from physics and all those things, physics informed machine learning. But generally the accepted definition is that you will want your model to learn from data. That is the definition, okay? But then what is it that you want your model to learn? There can be many things. And that basically that helps us in classifying machine learning algorithms. You might want your model to find a relation. You have data, input and output, and you might want your model to find a relation between that x and y. That's the supervised machine learning algorithm. You might you only have x and want to find some pattern in the data, like clusters, like what distribution it is coming from, and that is the unsupervised learning. And then there is reinforcement learning, which has this concept of action and reward kind of structure, okay? So if I talk about machine learning, it is broadly classified into supervised learning, unsupervised learning, and reinforcement learning. Okay, these are the three categories that you can divide your machine learning algorithms into. Supervised learning is more like I am teaching you, so you are learning through my supervision. So that's a supervised learning setup in a philosophical way, but in a mathematical way it's more about so in this case you have x and y, so your data will be labeled. So x is your data and y is the label, we call your data is labeled. Example, suppose in this classroom I collect height and weight of all the students, all of them, okay? So height and weight will go into my x, and corresponding to height and weight I also have a y, which is like whether the student is a male or a female. So then y becomes my label. So x is height and weight of the students, y is whether the student is a male or a female, okay? So that is label data. And from here what you will want to learn? You will want to learn a relation between x and y, so that tomorrow if some new student register, you can put it in that model, mathematical model, machine learning model, that will take the height and weight of that student, the new student, and will tell or predict whether that student is male or female. So that's an example of supervised learning. It's about learning function, learning mapping from x to y, okay? Unsupervised learning algorithm, you do not have y, you only have x. That will be unsupervised learning. So you have unlabeled data, your data is not labeled. And in that case, what will you do? What will you want to learn? For example, you might want to learn the distribution of x, probability of x. You might want to learn make a cluster out of it. And if you make a cluster, your cluster might look something like this. I don't know, but maybe. Let's say this is height, this is weight, and you might have clusters like this. And so like that, if you plot it, you might get data sets which are clustered in that manner. And you might want to know this. It's easy because it's 2 variable. If think of it as 100 variable, you cannot do it by plotting. So 2 variable is easy, 100 is not. Okay. So that is example of unsupervised learning. So it is more like you are learning yourself by reading a book, just to draw parallel comparison, right, or philosophically. Third one is reinforcement learning. Here the idea is, so I will say this is how human beings learn mostly, at least a child learns. So the idea is here, there is a concept of agent, there is a concept of action, there is an environment, there is a reward, and you learn based on these 4 things. What is the environment? Environment, let's say, is this classroom. What is the agent? Agent can be you, agent can be me, agent can be someone in the environment, something in the environment that can take action. Okay. Then action is action, doing something. Reward is getting something positive or something negative. Negative can be a punishment, so negative reward, positive reward. For example, I am here trying to teach probabilistic machine learning to all of you. That is my environment, everyone's environment. Your environment is you are trying to learn, I am trying to teach. That is the environment of this classroom. Okay. Agent, you can be agent, I can be agent. Let's say I am an agent. So then my goal is to ensure maximal teaching or maximum learning for you. That is my goal. So what will I do? I will use or I will try out some way of teaching, maybe giving notes, giving solutions and all those things in practical and all those things. And based on that, you will give an exam, and from that exam probably I will judge whether you have learned or not. Suppose everyone is getting relatively more than average marks, and average compared to what I expect in that sense. Okay. In that case, I know that okay, this method is working, you are learning, so I will follow that method. But it is possible that you are not able to learn. Naturally, you are asking a lot of questions after the class. Also, although obviously asking question does not mean you are not able to learn, you might have questions, but just as an example. Okay? But definitely you are not performing well in the exam, most of you. In that case, I know that okay, I might be thinking I am trying to teach, but obviously there is a gap, so I need to adjust my teaching style. So I took an action which is certain way of teaching. I got the reward in form of your exam results, and based on that I will modify my teaching style, and this will happen over years, maybe 2-3 years, and hopefully by the end of 2-3 years I will achieve something optimal way of teaching this course. This is reinforcement learning. This is how human works. This is exactly how I work, right? You on the other hand will do the same thing. You will try to learn the maximum things, and you will realize that okay, maybe only attending the lectures are not enough. You will start watching videos and come back here. In that case, you will realize that okay, it is easy to follow and all those things. And you will also adjust yourself based on how much you are able to grasp in a class, and you will try to reach the optimal state so that you can learn the maximum. This is reinforcement learning. Okay. And this is mostly how humans operate. We take some action, based on that we get some reward, and based on that we adjust our action. So that is basically your reinforcement learning. In this course, we will not cover reinforcement learning. That's a separate course of its own. I think there is one course that is running in School of AI this time. I am not sure, but I think one course in electrical might also learn on stochastic control and reinforcement learning. So those are separate courses actually. So we will be mainly focusing on supervised and unsupervised learning, and even there we will be focusing more on supervised learning. Like 75% of the course will be on supervised learning, and only towards the end 25% will be on unsupervised learning. Okay. Interestingly, the advanced topics are all on unsupervised, the flow and all those things. Okay. And the reason is that it is probabilistic machine learning for mechanics. In mechanics, you have application of both, but application of supervised is more. Weather prediction, for example, is a supervised learning problem. For example, response prediction is supervised learning problem. Finding pattern might be unsupervised learning. Okay, so this course will be mostly about supervised learning, although we will cover some portion of unsupervised. Also, reinforcement learning will not cover, and that will also not be allowed to take as a term project. So term project or whatever will be from this two only. Nothing of this will be allowed. Okay, but if you are interested in reinforcement learning, I am really interested. I work in reinforcement learning, but you have to study on your own if you are interested in that. Okay. So this is supervised, unsupervised, and reinforcement learning. Okay. Now this course is about, there are two aspects of this course. There is machine learning, actually three aspects, and then there is probability, and then there is mechanics. So we discuss something about machine learning, which you will see throughout this course. Let us discuss something about probability now, probabilistic fact. So the idea is, what is probabilistic machine learning? And if I am talking about probabilistic machine learning, there should be something non-probabilistic also. There has to be, otherwise we would have just called it machine learning. What is probabilistic? So the idea of probabilistic machine learning is, in fact, before that I will say that probability, right? I always say probability is not a subject. It is a way of thinking. That's how I see probability. It's a way of thinking. And probabilistic machine learning is about bringing that way of thinking into machine learning. It may not be in the machine learning, it might be in a physical system, and that's what we cover in uncertainty quantification. But here we will only cover about bringing that way of thinking into machine learning. Okay. So let us just take one example. Okay. Suppose I mean, all of you have mobile, right? Smartphone. If you open your smartphone, you can see that it predicts the weather for, I think, next 15 days now, 10, 15 days, something like 10 days or something like that, right? Now, is that correct? What it is predicting? Is it predicting perfectly? Okay. There is some probability, we'll come to that, but even before that, is it predicting almost perfectly what will happen 1 hour from now? 1 hour from now, probably it is quite accurate, I will say. 1 hour, right? If it says it will rain, it probably rains. Temperature is anyways accurate. Rain is the problem. But it can predict with certain accuracy 1 hour from now. If I look at 1 day, it is less accurate than 1 hour. If I look at 7 days, it definitely changes. Nothing matches 7 days. So that means, yes, you can predict using machine learning, but are those predictions reliable? How will you know? You need a metric to know whether your predictions are reliable or not. And for that, you will need some probability measure. So for example, if I ask you, or you ask me whether it will rain in or 1 hour or not, or 15 minutes or not, I will say no, it will not rain in 15 minutes with quite certainty. Let's say 95% confidence. But if you ask me whether it will rain in another 5 hours or not, my confidence will go down to 50%. If you tell me whether it will rain tomorrow or not, maybe 20%. So this percentage that you also see in your mobile, that it says that 95% chance of rain, that is the uncertainty aspect, that is the probabilistic aspect. And if you want your model to be able to do that, if you want your model to give you bounds, if you want your model to give you a confidence interval, then you have to make your model probabilistic. So the idea of probabilistic machine learning is to bring this way of thinking of probability into machine learning, so as to allow your machine learning model to provide confidence interval, and along with that there are other advantages which we will talk later, not today. Okay. So that is the idea of probabilistic machine learning, and you will realize that I might have exact measurements of weather until today. Even then my predictions are not certain. I cannot predict with certainty. And this uncertainty that I'm talking about, this probability aspect if I'm talking about, this also is dependent on how much data you have. A simple example, I give you a coin and ask you what is the probability of head. How will you find it out? I don't know whether the coin is biased or unbiased. We have studied if it is unbiased, it will be 1 by 2. But I don't know that. And I ask you to find out the probability of getting head. How will you find it out? Toss the coin. Let's say I toss the coin 10 times. So the idea is right. We'll toss the coin and then count how many times I observe something, that is ratio. So let's say I toss the coin 20 times. Got 11 heads. Okay. So what is the probability? 11 by 20. And in the second time I toss the coin 2000 times. Got 1100 heads. Right? What is the probability? Same. Now, if I give you both these estimates, will you believe both of this, or which one will you believe more? 2000. Why? Because you have more data. That you know, right? That because I performed, because ideally you should perform the experiment infinite times. So you want to perform this experiment as much time as you want. So then you know that, but your model, it is giving same thing. With probabilistic machine learning, it will not only give 11 by 20, it will also tell you, okay, 11 by 20 with this percent. And that percent will be more, confidence. So it will be more confident in that, it should be more confident in the 2000 example rather than in the 20 example. That is what we want to enable in this course. And naturally, you will realize that this thing becomes very important if you have less amount of data, sparse data.
Then confidence comes from data.
Then confidence comes from?
We can say confidence comes from.
Then confidence comes into play, because if you have less data, then you really want to know whether am I even getting something reasonable? Because if I have infinite or many data, I am fine. Why should I care? Even a point estimate is fine. Like instead of 2000, if I toss that coin 2 billion times, then whatever data you will give me, I'll say, okay, I will believe it. That is what the probability is. So the point I'm trying to make here is, if you have less data, then getting a confidence interval is very important, because that will tell you whether you can trust that model or not. And as it happens, in real world, data collection is expensive, even today. Weather model, right? The same example. Why do you think it is not accurate? It is not accurate because you only have weather stations at certain locations. If you have weather stations everywhere, then it will be more accurate. Because based on those stations at other rural areas, you extrapolate or interpolate. And that itself is erroneous. And based on that, you are now predicting. So what are you expecting? Yes, there is satellite image, if you want to think. But even satellite image do not have the adequate resolution as of now. And also, when I say less data, it's not only about space, it might be in time also, at what is the frame rate you have. Okay. So that is why it is needed. So one of the cases where it is needed is, as I said, so probabilistic ML, one of the cases when we have sparse data. Okay. That is the case where this becomes absolutely important, and for mechanics problem, doing experiment collecting data is very expensive. So it's very important. The second case is for important systems. Think of a nuclear reactor. Will you even trust a machine learning model to use it in a nuclear reactor? Because if it fails, and if the system fails, we are talking about cities. A city, people in a city can die. So in that case, your model has to be absolutely accurate. And if you want to use machine learning for those kind of things, you definitely need a very good estimate of uncertainty. No other choice you have. So that means that is the second case. It is important system, hospital, nuclear reactor, where failure might mean loss of many lives. So second one is important systems. Okay. There are other cases also, but those are more mathematical reasons that we will only do when we go into depth of these things. There are mathematical reasons also that probabilistic machine learning can give, like immunity to overfitting. Probabilistic machine learning can give you immunity to overfitting. Okay, so overfitting does not happen, and all those things it can, but for that we will do it separately when we go there. So yeah, so these are the reasons that probabilistic machine learning is needed, specifically in mechanics, but everywhere else. But then, which one is more popular? Is it probabilistic machine learning or non-probabilistic machine learning? Non-probabilistic. Why? If it is so important and so good, why is it not? Why is not everyone using it? The reason is computational cost. Probabilistic machine learning is significantly costlier computationally than the normal one. Like machine learning for neural probabilistic, let's say you want to develop a Bayesian neural network. Very difficult. Okay, very difficult Bayesian neural network. If you want to, yeah, there are probabilistic neural network, but not Bayesian. So Bayesian is very difficult and it's very expensive. So the reason that probabilistic machine learning is not that popular in industry, at least today, is because it is still in a developmental phase. You want to accelerate it, you want to do it from minimum number of samples, you want to get or ensure that it is applicable even in neural network kind of setting where you have millions of parameters. So that's why there are certain aspects of probabilistic machine learning that are currently in a research stage, not in the deployment stage. Whereas machine learning, the normal one, many things are in the deployment stage. Having said that, there are certain companies who will not accept anything apart from probabilistic machine learning. For example, aircraft engine industry. Aircraft. So, because if you do not do a probabilistic assessment in an aircraft, then they will have no trust, and aircraft is an important system. If it fails, we are talking about life loss in hundreds. So aircraft industry, absolutely, if you have to use machine learning there, they will want to have some sense of uncertainty measure. That might not be the best way, but they will want some uncertainty measure. Because without that, they cannot trust it. They will just use the conventional thing, because obviously the cost of life is more important than doing it faster. Okay. So that is the reason. Okay. Now coming to mechanics, why the third thing, right? We talked about probability, we talked about machine learning. The third one is mechanics or engineering in general, let's call it. So coming to the third and the last aspect for today, the mechanics aspect. Why is ফোনটা রিসিভ করো, রিসিভ করে কথা বলো, বলবেন ক্লাসে আছি, আধ ঘন্টায় করবো। Okay, the third one is probabilistic, the mechanics part. So the one question is that for mechanics has a very long history. Like Newton, Euler, that's where it started, right? Newtonian mechanics, Lagrangian mechanics, Eulerian mechanics, Hamiltonian. So it has a very long history of, and when something has such a long history, in that case, there will be a lot of development that might have happened over years, 400, 500 years. There is definitely finite element method, finite volume method, CFD, FEM and all those things, finite difference method, and all of those things. Classical control, if we talk about control and all those things. So the question is, if all of those things are there, then why do we need probabilistic machine learning or machine learning for, let's say, why do we even need machine learning? Can't we just use finite element? Can't we just use finite volume or any numerical method? and solve it. Yes, you can use finite element, but even today with modern supercomputers having thousands of CPUs and cores, it takes huge time for solving a problem that involves repeated simulation. One example I can give you, two examples, let's say. So Navier-Stokes equation, right? Let's say I have a 3D Navier-Stokes equation and I want to solve it using direct numerical simulation, which is the most exact way possible. It can take months. I mean, it can vary from weeks to months depending on the size of the system, but it can take months for you to get one simulation result. Now imagine you want to optimize something. Let's say optimize the shape of a hull. Then that CFD simulation is the inner loop. There is an outer loop of optimization, and you might need to run that 1000 times in sequential because optimization, not parallel. You cannot parallelize it. Then you cannot solve that problem. You don't have 1000 months, for example. Similarly, if you go to materials, there is something known as DFT, which is known as direct functional theory. Not direct, I think discrete, I think, right? So there is DFT, and the full form might be wrong, but and that is based on quantum and all those things. And that is even more expensive than DNS. So definitely that's not an option then. Even molecular dynamics is expensive. Finite element is also expensive if you have a very fine mesh, very large structure and all those things. So there are scenarios where you just cannot use finite element in its full scale. You can reduce order model and all those things you can use, but then you are going into unsupervised learning. And in those scenarios, machine learning has a role to play. Okay, so application in mechanics. One of the reasons that I said is computational efficiency. The other one is there are still places where the mechanics is not well known and we rely on approximations. For example, constitutive relation. All the constitutive laws that you know are just empirical relations. So if we are anyways using an empirical relation, why not use a machine learning model that will give me at least better result? Okay. So there are also missing physics basically that I am trying to point out. There are many places where there are missing physics. And in that case you have to, this has lots of application. And you will realize that, you will see that the last practical is on equation discovery from data. You give me data, I will discover the equation. So that is the last practical, so maybe in October, November we are talking about, but there is one practical on that. Okay. So just to summarize, this course is about probabilistic machine learning for mechanics. It will involve probability theory. Please go and check out the lectures from last year if you want a recap of things, because we will do it very fast like next time, and then we will go slow. Machine learning although includes supervised, unsupervised, reinforcement learning, we will mostly be covering supervised and unsupervised, not reinforcement. Even then we will be covering more of supervised as compared to unsupervised. And the mechanics component, I did not tell you actually, this course probabilistic machine learning for mechanics, the lectures will be only about probabilistic machine learning. You will not find any mechanics in the whole course, at least in the 300 part. You will find some mechanics in the 002 part, because the data set I will be giving you might be from mechanics. But other than that, although the course is probabilistic machine learning for mechanics, it's mostly on probabilistic machine learning, the mechanics is only in the practical component. So that's why the name. So it is 300 plus 002. 300 has nothing to do with mechanics. Okay, it's just data that we care about. 002 has something to do about mechanics. Some initial stage might not even have mechanics, but ultimately it will have.
have some information about mechanics, knowledge?
No. For this course, no. Okay. Because the data, if I am providing the data, then you don't need it. Mechanics is needed when we teach physics informed machine learning, but that is in deep learning, not here. So here we are not doing that. So for this course, I don't think you need any background in mechanics. You need background in the other aspects. Okay. Yeah, and if some question somewhere in the whole scheme of things has some mechanics, that details will be provided to you. So that background you will not need. Okay. So in the next lecture, which is on Thursday, we will be starting with the actual. This was like nothing. Okay, this was just talking and talking. I did not even write 2 slides, I think. Okay. So yeah, the real thing will start from next lecture. Actually, the real thing will start from next Monday when I actually start with machine learning. And next class, I will just be reviewing very quickly some of the things in probability and statistics. So my recommendation, strong recommendation, is that please go through those, review your probability and statistics stuff from wherever you want. I don't care, but please review it before coming to the next lecture, because otherwise it will be difficult for you to follow at least the next lecture. So please review or read probability and statistics. And what are the things you will need? I'll tell you. You will need the sum law of probability, product law of probability, Bayes rule, conditional probability, conditional independence, Gaussian distribution, Bernoulli distribution, binomial distribution. So this kind of things, okay, which you have probably studied earlier. Okay. Now remember that this course you will realize that the statistics you know, and that's a prerequisite actually. Although there is a statistics component that I expect you to know, but you will realize that we will be working with multivariate statistics, which probably none of you know. So don't worry about that. Multivariate is just extending univariate to multivariate, and that will do parallelly as the problem comes. So we'll not worry about theorems and all those things, proving those things in statistical sense. We'll rather be more practical and worry about using the stuff for machine learning. But you will realize that it will be more about multivariate statistics, and that is why vector algebra will come into picture, matrix algebra will come into picture, and all those things will come into picture. Okay. Any question? So we'll next meet on Thursday, where we'll review the probability statistics part, and then the real machine learning stuff starts from next Monday. Next Wednesday we'll have practical first. Okay. Thank you.